Welcome to Code Sutra. In this video, I will be discussing about LeetCode problem number 783. Actually, this week in LeetCode daily challenges, it's an easy week. We have people divided across. Some people are like, let's enjoy the easy week. On the other hand, we have people who are like, there's no kick in solving this problem, right? We can easily get these answers. Okay, without further ado, let's get into the solution. So, what is asked in the question? In the question, we are given a binary search tree. Remember, it's a binary search tree, not just a binary tree. And what we have to do, we have to find the minimum distance. Actually, this statement is quite confusing. It's not the minimum distance, it's just the minimum values between the two nodes. For example, in this particular example, if you look here, what is the difference between this node 4 and this node 1? The difference is 1. It's not the distance is actually 2. It's just 1 and 1 node. But actually, what is the difference between the actual values? It is 3, right? Similarly, what is the difference between 6 and 1? It's 5. So we have to find the minimum difference. For example, in this question, the minimum difference is between 1 and 2 as well 2 and 3, that is equal to 1. So actually, what is a binary search tree? Why is it so important? So in a binary search tree, the left node is always lesser than the parent node and the right node is always greater than the parent node. For example, in this example, 1 is lesser than 2 and 3 is greater than 2. But if you take here, is this a valid binary tree? No. Though 1 is lesser than 4, 3 is not greater than 4, so this is not a valid binary search tree. So actually, what is so important about a binary search tree? So whenever we do the in-order traversal, right, the in-order traversal will be in sorted order or the ascending order. What is in-order traversal? For example, is this a valid binary search tree? Yes, this is a valid binary search tree. For example, if there was 26 here instead of 24, this node, will it be a valid binary search tree then? Instead of 24, we have 26. No, right? Because if there is 26, it will be greater than this 25, which is not actually valid. Why? Because it means that the entire left tree has to be lesser than the parent node and the entire right tree has to be greater than the parent node, not just the immediate children, but the entire left and the right tree. So what does this mean? Let's do the in-order traversal. What's in-order traversal? We will first visit the left tree, then the root node, then the right child. So for example, what happens here? 25 will go to 15. So 15, does it have left child? Yes. 10. Does 10 have a left child? 4. Yes. Does 4 have a left child? No. So we will print 4. Then again 10, does it have a... So we already printed the left child, so we will be printing 10. Does it have a right child? Yes, 12. Then what is it? 15. All the left nodes are printed here. If you look at 4, 10 and 12 are printed. Then we will actually come to 15. Then we will print 15. Then we will come to the right node, 22. So since this already has a left, we will go to the left. 18. Does it have left or right? No, it doesn't have a left or right. So we will just print the value. Then again 22 and 24 and so on. So what will be the actual order of this? So this will be the complete in order traversal. So if you look here, this is completely sorted in the ascending order. Why it will be sorted in ascending order? Since it's a binary search tree, we are visiting all the left nodes. What does it mean? The left node will be lesser than the parent node, so it will be in the sorted list. So this is the logic for in order traversal. What we are just doing, we are just calling the same function in order, and we are calling the left child, then we are calling the right child, but in between we can print the value also. So for 4 we are printing the value, or in this example we can do any particular operation. You can solve any problem that requires in order traversal in this particular point. That is in between calling these two particular nodes. And if it is the root is equal to null, we will just return it. This will be a void function. Okay. So now once you have all these elements, you can either store this in an array or you can store this in an array list, and you can just iterate over the elements. For example, what will be the minimum difference? The minimum difference will be the difference between any two consecutive elements, right? The difference between 4 and 12 will always be greater than the difference between 4 and 10, right? Because it's in sorted order. So the difference between any two elements will be the least. So we go on. What is the difference between 10 and 4? It's 6. So our minimum will be 6. What is the difference between 10 and 12? It will be 2. Our new minimum is 2. So again, 12 and 15, it is 3. Do we want to change the value? No. Similarly, we go on, and if you look here, the difference between 24 and 25 will be 1. And that will be our answer. Okay. So, but here we are using extra space. That is, we are using a array list. So how can we actually reduce this? Can we reduce this? Yes. How? So we keep track of the previous node. We just require the previous value, right? For example, here, once you are here, you don't need all the previous value. All you need is just 18. Similarly, once you are here, you don't need all the values. You just need 50. That is, you need to keep a track of the previous element. So let's do in this example. What 25? Once we are at 25, what will be the previous node? The previous node will be empty. And the minimum value, it will be the just equal to infinity. Okay, so we come to 25, we then go to 15. Does anything change? No. We still go to left. 4. Does it have a previous value? No. If it doesn't have a previous value, then we will change this to 4. And this doesn't get changed because there was no previous value. Then again we will come to 10. So when you come to 10, is there any previous value? Yes, there is a previous value. So we compute the difference. And what will be the minimum value now? The minimum value will be 6, and we will also change the previous node to 10. Similarly, we go further. We go to 12, and what will be the difference now? The difference will be 2, and we will also change the previous node's value. And we again come to 15 here. Does the minimum get changed? No, right? Because the difference is 3, but the minimum is already 2. So we change the previous value to 15, and so on. We go that, and we get the minimum value when it's 24 and 25. The previous node will be 24 and the present node will be 25. So let's dive into the code. So before diving into the code, a small update. Actually 99% of the viewers don't subscribe to the channel. So if you are enjoying the videos and learning from the videos, please do consider subscribing to the channel, and please do consider watching the interview series or the placement series. We don't just solve the problems here. We take a pattern, we identify the pattern, and we then solve problems that is related to particular patterns. Okay, we solve questions from most of the FANG companies in this particular videos. So if you look at the code, what do we do here? The previous and the minimum values are outside. Why? Because the inOrder function has to change these values every time. So these are outside the function. If it was inside the function, right, these values won't get updated globally, right? So that is why we have kept these two values globally. That is outside both the functions. That is the previous. Initially it will be null because we don't have any values. Then the minimum will be, we have just initiated it to infinity. So if you look here, we have created one more function called as the inOrder function that we just discussed in this slide, that uses this formula. So what was the actual need of using a different method altogether, right? So it will just help us to do the inOrder traversal. We are just creating one more method instead of just using this method which has a int return value. We are just creating one more function with void return value because it will help in the inOrder traversal. So everything else remains the same. In inOrder traversal, if the root is null, we will return, that is, we will return nothing. Then we will call the same function with left node. Then we call the right node. But in between, what are we doing? We can do any calculation. What are we actually doing here? If the previous is null, that is, this is the first node, we do nothing. We will just change the previous node to the current node's value. If there is previous node, what are we doing? We are just changing the value. We are computing the current difference. And if the minimum is lesser than the current difference, we will just update the minimum. And finally, we will return the minimum value. So this is Java and this will be C++. Thank you for watching the video.